Hello, good day viewers. Welcome to another mathematics presentation. So in this presentation, I want us to answer a question that came in Mathematics Paper 1 for 2024 for internal candidates. So this is a question that is coming from Earth Geometry. The question reads, the diagram shows the position of towns A, B, and C on the surface of the Earth. So this is the diagram which is showing the position of towns A, B, and C on the Earth is what? Surface. So here is our question A. What is the time at C when the time at A is 11:22 hours? So they want us to find the time at C when the time at A we have been given that it is 11:22 hours. So how can we find the time at point C? So to find the time at point C, we need to take into consideration that we need to look at the longitude where C is lying on. So C is lying on 45 degrees east and A is lying on 75 degrees west. So what we are going to do first, we need to find the difference in longitudes between point C and A. So the difference in longitudes, since E is lying on 45, so the difference in longitude, okay, the difference in longitude you are going to have, so C on 45 degrees east, A on 75 degrees west. So since they are lying on different hemispheres, this one on west, this one on east, we are going to add. So you say 45 plus 75. We are going to add them because they are lying on different hemispheres. But if they are lying on same hemispheres, I would have subtracted. So 5 plus 5, it's a 10. We write a 0, we carry 1. 4 plus 7, it's 11, plus that one we are going to have 120 degrees. So this is the difference in what? In longitude between point C and A. So after finding the difference in longitude, we are now going to find the time difference. So to find the time difference, you say time difference between point A and B, C is going to be difference in longitude. So the difference in longitude between C and A, we have found that is 120 degrees. Then we divide by 15 degrees. Okay, so in case we are wondering where this 15 is coming from, so we know that the Earth rotates 360 degrees on its axis for every 24 hours, meaning that in 24 hours the Earth will rotate an angle of 360 degrees. So in 1 hour the Earth will rotate at 15 degrees. So just divide 360 degrees divided by 24. That's where this 15 degrees is coming from, because it's the rotation of the Earth in 1 hour. So get this difference in longitude divided by 15 degrees. So what are we going to get? Okay, so here we can do this. 15 can go into itself 1, then 15 into 120, it's 8. So we are going to get 8 hours. So the difference in time between point C and A is what? 8. So after finding this, what are we going to do now? We are going to say, therefore, so we need to find the time at C. So therefore, the time at C, we'll get the time at point A, which is 11:22 hours. Okay. Then we are going to do what? To add with the 8 hours. So plus 080 hours. Okay, so now in case you are wondering why are we adding, so the reason why we are adding, we are looking at point C. Point C is lying on what? East side. So meaning that it's going to gain time. Okay, point C is lying on east, so it's going to gain time. So we are going to add 2 plus 0 to give us 2, 2 plus 0 to give us 2, 1 plus 8 to give us 9, 1 plus 0 to give us 9. So the time at point C is going to be 19:22 hours. Okay, that is our answer. We now move on to our question B. Question B reads, a plane flies from point A to point B in 9 hours. Calculate its speed if the distance between A and B is 7,200 Newton-miles. So here the distance in Newton-miles, so meaning that the speed is going to be knots. So the formula that we are going to use, speed is equal to distance over time. So we have been given the distance, which is 7,200. Okay, then So we have been given the time between point A and B, as you can see there, which is 9 hours. Okay, so where there is time, you're just going to put a 9. So say equal to 9 here 1, 9 into 72 to give us 8. 1 into 8 it's 8, and the 2 zeros, we have 800 knots. So this is our answer.